Hi everyone, welcome back to my channel. Today let's discuss about environmental protection. Today's topic, the intersection of value engineering and sustainability in building construction. Abstract. Building construction is an integral part of national economic development. Nevertheless, it requires enormous capital to implement sustainable building construction. Construction activities contribute to environment degradation and population by material extraction and carbon emission, amongst other problems. Stakeholders in the industry continue to seek ways to optimize resources to save cost and protect the environment. Value engineering VE seeks to strike a balance between cost and functions performed by buildings and infrastructures without compromise. Therefore, the survey aims to understand how VE principles can optimize building resources and protect the environment without loss in quality, performance, and reliability. The assignment reveals the using V principles optimize building function at the lowest overall cost without affecting quality and performance. The approach addressing the oversizing of structural elements of building and mechanical and electrical system. It resolves the complexity of building sizes and shapes by material div- diversification. It identifies the function of a building before investing to save cost and avoid project ab- abandonment. The practice has the potential to provide an environmental advantage through the demonstration of the building structure to mitigate greenhouse gas emission linked to the built environment occasioned by the energy released from fossil fuels. The more method simplifies multi-objective resources optimization of associated with super tall building construction. In addition, abandoned projects can be reviewed by identifying the status and challenges with the project and suggestion strategies that facilitate the each easy take off of the rehabilitation of such project. Furthermore, building projects can achieve green and sustainable construction by adapting value engineering strategies. Keywords: value engineering, building construction, resource optimization, environment, population. Introduction overview. Building construction is essential for economic deployment development but contributes to environmental challenges like material waste and carbon emission. Value in engineering VE focuses on optimizing resources by balancing cost and function without compromising quality. VE principles help achieve sustainable construction by minimizing environmental impact while maintaining performance and reliability. Value engineering VE principles, VE roles. VE is a systematic approach aimed at improving project value by balancing cost and building functions. Optimizes buildings functions at the lowest cost without compromising quality or performance. Focuses on reducing oversize of structure and on elemental specifying complex design and diversifying material use. Environmental impact of construction. Environmental concerns. Constructions activities contribute to environmental degradation through material extraction and high carbon emission. VE roles minimizes material use, improve energy efficiency in building projects, reducing the environmental footprint. VE and resource optimization in building construction. VE as a tool identifies key building functions early in the project, allowing stakeholders to invest resource effectively. Helps review abandoned project by addressing challenges and optimizing project viability. Supports multi-objective optimization in the construction of super tall buildings to balance structural integrity and material use. Case study: Energy efficiency in Kuwait. Kuwait's case study: we reduced construction cost by 11% in residential buildings through optimized design and energy efficiency measures. Energy efficiency measures reduced the building's annual energy demanded by 70%, reduced use of concrete and steel in the structure, leading to a more sustainable design. We for sustainable construction. Sustainable practice: we facilitate green building strategies to reduce environmental impacts. Life cycle assessment helps manage carbon emission and construction waste. We enable reduction in greenhouse gas emission linked to fossil fuels usage in building projects. Challenges and opportunities in we implementation challenges. Over implementation we could lead to unforeseen environmental or economic problems. Unprofessional practice in project planning and execution can hinder VE's effectiveness. Opportunities: provide significant opportunities for improving resources efficiently, promoting sustainability and revitalizing projects. Conclusion summary: VE is a powerful tool that balances cost and functions in a building construction without loss of quality. It supports environmental protection through sustainable practices and resource optimization. Further future directions: stakeholders must incorporate VE in future projects to enhance sustainability and efficiency in the construction industry. References. Thank you.